The goal of this problem is to illustrate how nice these energies are by trying to make it a little bit harder, and it turns out these energy equations work a lot nicer than the kinematics way. So in our previous problem, it was one-dimensional. Maybe you can use the kinematics equations and they're not that bad. In this one, we now have an angle, thus making you have to use lots of trig and break things down into directions if you use kinematics, but not for energies. Energies are very simple, and I wanted to do this problem to illustrate how nice it makes things with angles. So, in this problem, we have a block that is rolling down an inclined plane. The plane is angled with 45 degrees. And we have our block. It has a mass of 0.5 kilograms. And it's frictionless. And 2 meters long. So the hypotenuse of our triangle is 2 meters long. So from here, let's use a different color. Green. From here to here is h. This distance. Okay. So, since there's no friction, this is going to slide down, and our box will come down to the table and be moving with some velocity v, final, that we don't know. How fast is the block moving is a kinematics problem. You could draw the sum of all the forces and find the acceleration and then plug that into your kinematics equation. Or you can use energies. So, at this point here, this point here, our velocity initial is 0. And our height from the ground, so let's say this is our ground, we're going to call it y. We can find y using trig. So let's do that. If we have a triangle, and we know the hypotenuse is 2, and our angle is 45 degrees, opposite, adjacent, so sine of 45 degrees is equal to y over 2. So y is 2 sine 45 degrees. Which is 0.7 times 2 is 1.4 meters. So we can find our initial energy by looking at the kinetic energy initial this is 0 because it's not moving initially, and the gravitational potential energy initial. This is just m times g, and we called this y, so we're going to leave it like this. So our total energy before we let it roll down is 0 plus mgy. So our total energy before is mgy, and that is a known number. We'll plug it in at the end. If we go back to our problem, down here, we have an unknown v final. We're going to just call it v. We also know our height. Y final is 0, because it's on the ground. We define this point here to be 0. So, we have the kinetic energy final is 1/2 mv final squared, which is our unknown, 1/2 mv squared. U final is mgy final, but that's just 0. So our final energy is 1/2 mv squared. And now, we use the conservation of energy. The E initial is equal to the E final. E initial is mgy. E final is 1/2 mv squared. The m's cancel. So we get gy is equal to 1/2 v squared. G is 9.8. Y we found was 1.4. 1/2 v squared. So, all right, 1.4 times 2, or times 9.8, is 13.86, is equal to 1/2 v squared. So we're going to multiply both sides by 2, so that the 1/2 and the 2 cancel. So times 2, 27.72 equals v squared, and then we'll take the square root of both sides. Which is v equals 5.26 meters per second. And that is our velocity of our box sliding down a ramp without friction. And I think doing it with forces and with kinematics would have taken about 5 times longer. So a lot less angles and a lot less worrying.